continuing on in lesson 1.5. So let's just put that this is going to be called lesson 1.5, notes 2. We did a notes handout the first time in this lesson. Now we're going to continue on. We're going to take like 4 days worth of notes in lesson 1.5. It's a really important lesson to make sure we understand how to do these things. So we're back to the first thing we're going to look for today is, do we need to do some simplifying? So we're going to simplify and then solve. Okay? So really important that today you look for what can be simplified first before I start my steps of solving. So we're just going to go right to practicing. So you can just put practice and practice with me here. Okay, here's our first one. We have, carefully write down the equation that I put up here and then we'll take it from there. 10m, subtract 12, add 2m equals 6m. We got m's all over the place in this one. So there's our equation that we're going to first look at and say, how can I simplify it first? And then go about the actual solving from there. So, anybody know what the first thing I'm going to expect you to do in this problem is, though? What do you suppose the first thing I'm going to expect is? Aurora?
Change the subtraction to addition.
Yeah, change the subtraction to add the opposite. Now, again, we got to be careful and not just say just addition, only because we can't just change subtraction signs to addition signs. We also have to change the one thing that is being subtracted right behind it to its opposite. Okay, so go ahead and catch up here, Cody. I'll try and leave that up there for you so you can. So we're going to rewrite it on the next line, saying 10m, what? Plus what? Negative 12. Do we have any other subtraction to change? No, we're going to leave those additions as they are. We're not going to mess with them. So we haven't even started simplifying it. We're just kind of like making it more user-friendly so that we'll be more successful. Okay. Can we do some simplifying?
Add the 10
Okay, the 10m and 2m are on the same side. Because notice we got m's over on the other side too, don't we? So can we just bring all three of them together now at the same time? No, we have to work. Remember when we simplify, we look on sides only and we say, can I do something on this side to simplify it? And Jossie just said, you know what? We can put these guys together. This 10m plus this 2m can be combined because they're on the same side. And what's that going to become? 12m. And then our tag along that's in the middle there has to come along. And get rid of it. And then bring down our equals 6m. Okay, do we have any more simplifying we can do? Any other simplifying? In other words, are there any, is there any distributive property to do, any parentheses to get rid of? Remember, that's one of the simplifying steps. And the other simplifying step is combining like terms. We just did a combining like terms one, didn't we? Okay, do we have any other like terms that can be combined? Cody, which ones would you like to try and combine? Okay, but the 6m and the 12m? But they're on opposite sides of the equation, so we can't. That would not be called a simplifying step. You're trying to move into solving, I think. We don't have any parentheses, we don't have any distributive property to do, so I think we're ready to start solving, aren't we? So let's make that note in our notes that this is ready, right here. This is where we say it is ready to solve. Okay, we've done what we need to do to get it ready to solve, and now we can go about our solving steps. Okay, so what should we make our first move there, Jossie?
Subtract 12m on both sides.
Subtract 12m from both sides. So we got m's on both sides, so our thought is, you know what, I only want them on one side. And why are we going to move the 12m? Why did you decide to move the 12m, Jossie, instead of the 6m? I asked you the same question, I think, yesterday, didn't I?
I don't know. I just, because
there's also a really good reason, and I like it the way that you're going to do it, Julia.
Because you want the 12M to be by itself.
You want the 12M to be by itself. We want some M's to be by themselves eventually, but she wants to move the 12M. Why does she want to move the 12M?
To get them on the same side.
To get them over to the other side, on the same side, but why not move the 6M? Remember we said, oftentimes we like to move the smaller number of them so we don't have to deal with negatives. Didn't we say that? So why are we moving the 6M instead? What's our thought? What doesn't that side that has 6M have that the other side does have? A constant. It doesn't have a constant being added to it. So that's why. When we have a side that's just got variables on it by itself, and the other side has a constant with it, we're going to move the ones that have the constant. Okay, so that's why Jossie made a good choice to move the 12M. And we would subtract 12M. And is that what I heard you say, right? Okay. So now, these take care of each other because a 12M subtract a 12M, they're gone. What do we have now? Negative 12 comes down. And this can be changed to add the opposite, so we make a good choice here. 6 plus negative 12 is negative 6M. Again, and this is what you guys did to me a lot yesterday. You would say to me when I would see your fingers on your calculator for easy things, you'd be like, I was just checking to see if I was right. But when I don't see an answer down in your paper already, then you're not checking, you're answering. You're letting the calculator find the answer for you. So put your answer down then, and then let the calculator check it out for you if you're just, still not feeling comfortable with your skills with positives and negatives. Okay, what's going to be our next move here, Noah?
Divide by 6, both sides.
Okay, do you guys agree with Noah? He wants to divide both sides by 6. Oh, got some big shaking heads. Need to divide by negative 6. M is being multiplied by negative 6, so we divide by the same thing. And we can't say that 6 and negative 6 are the same thing and say, well, it doesn't really matter, that's what I meant. Well, sometimes that's what we say. Okay, so negative 6 divided by negative 6, what is that, by the way?
2.
No, negative 6 divided by negative 6.
0.
No,
1.
1. And so we really have a 1M. And that's just, is 1M the same as just M? Yeah, so that's why they can cancel like that. Okay, so we have M by itself now, and now we say a negative divided by a negative is a positive, and 12 divided by 6 is 2. So M equals 2. Okay. So I give you a 50-point quiz tomorrow, and I give you one problem to do. And I say you get all 50 points if you have the right answer. You get 0 if you have the wrong answer. Do you want to make sure you have the right answer?
Yes.
Yeah. Okay. How are you going to make sure?
Do a check.
Do a check problem. What would a check problem look like? What would you have to do to check this? Cody?
You would have to start back at the beginning and go, you would do the same thing about changing the subtraction to a plus and adding to the negative, and then changing it to negative, and then you'd add the ends that are on the same side, and then you would do, no, it's,
I like that you want to still change the subtraction to add the opposite, but what do you really do next? We're not solving anymore. We're not solving anymore. So we're not simplifying either anymore, Aurora.
You substitute 6 for M.
We
2 for M.
Yeah. We would substitute in all those places where there's an M, we would substitute a 2. Okay, we're going to do one check problem, and that's going to be this one, okay? So let's do a check problem together. Not saying you have to do them necessarily on your homework, but I want to know that we know how to do them, okay? So would you write down this, check? So we're checking to see if we have the right answer. We want 50 points, we don't want 0 points. So we're going to write down that we have 10M minus 12, whoopsie, not 12M, just 12, right? Okay, and that is plus 12. I should just look here, 2m, that's so messy. 2m equals 6m. So we write down our equation, and we're not solving. I'll just change it to add the opposite so I don't have to write it again. And now what are we going to do? We're going to substitute 2 in how many places? 3 places. So we're going to have 10, and substitute it in for m, we're going to have a 2, plus a negative 12, plus 2 times a, I was trying to keep a color thing going here and it didn't last, and 6 times 2. So every time there was an m, I put a 2 in. Every time. So we're not solving. We're not solving. Now what we're doing is we're substituting in and evaluating. That's what we're doing now. Now we're evaluating. What's 10 times 2?
20.
20, okay? Plus negative 12, we'll just bring that down. What's 2 times 2? 4. And 6 times 2? 12. Okay, we're not using our calculator, so we'll make our lives easier by just maybe taking this a couple more steps. 20 plus negative 12.
18. Positive.
20
No.
plus negative 12.
Positive 18.
Think about it. Did you have $20 and you give 12 of it away? How much money would you have? You'd have $8 left, wouldn't you? So 20 plus negative 12 becomes the 8. And everybody should be doing this. And now we have 8 plus 4, which is 12. And we bring down our equals 12 over here, and we say, is that a true statement? Does 12 equal itself? Yeah, it checks. Feeling pretty good about getting 50 points on the quiz. Okay. So we got to know that, sometimes even if you're not required to do a test problem, it might be a good idea just to do one to make sure that you got the right answer. All we're doing is substituting in and evaluating. So any questions? Okay, I'm going to write down one now, and I want you to go to work on it and see how it goes here. Here's how it starts. First step is going to be for everybody what? Add the opposite. Change subtraction to add the opposite. Next thought will be, can I do any simplifying? And what can I slip in front of that x also?
1.
A 1. Okay. So I slipped a 1 in and changed it to add the opposite. Can this one be simplified at all?
Yeah.
Okay. What do you think we could do for a simplifying step? Combine, are there some like terms? Okay. What are the like terms in this one? 5 and negative 21, they're on the same side, right? This time it's the constants that are like terms, not the variables, not the variable terms. So go ahead and get those put together. Everybody agree with me that when we add the constants, we get a negative 16? Okay. Somebody who has not offered up an answer yet today, offer up for us what we should make as our next move. So, somebody who has not offered up an answer yet today, offer up. Not leaving a whole lot of people that I have to pick on here. Okay, I'm gonna pick on Tori. Tori, what do you want my next move to be? Okay, can we combine them? Are we ready to solve this? Okay, it is ready to solve, so we're not gonna talk about combining, we're gonna talk about instead, what would be a solving step we could do. Calvin, what's a solving step we could do? We're ready to solve. So whenever we're ready to solve, that means our brain now says we gotta do the same thing on both sides. Ready to solve. Got an idea for me? I'll throw one out or not? No, Noah?
You subtract 1x from both sides of the equation.
Devontae?
Add 16. So, what is it? Yeah.
Tori?
Wait. Well, I subtracted, or added -1, and that's -8x equals -16.
Oh, did you add a negative one to both sides? Just like Noah wants to subtract 1x from both sides? I like that we're gonna try and do something with that negative 1x, but I'm not sure that I'm convinced yet we're doing it right. Aurora?
Plus 1x on both sides.
Yeah, we gotta add 1x to both sides because when a negative is being added, we add its opposite to undo it. So we add 1x to both sides. And sometimes we know what we should end up with, but we don't show this part correctly. We're showing it as adding maybe a negative and then but somehow the answer we get doesn't match that. So now we have 7x plus 1x on the left side. It is 8x. And what's left over here? Negative 16. Okay. Now the reason I didn't like the adding 16 to both sides, whoever offered up that, I think it was you, Devontae, maybe? Adding 16 to both sides is you were just going to create an extra step for us that I didn't want to do because I'm feeling lazy today. I just didn't want to do that extra step. Okay? Not saying that we couldn't have done that, Devontae. We could have. Okay, so now what would we do? Abby?
Divide both sides by 8.
Divide both sides by 8. And the 8 divided by 8 becomes a 1, so that we really just have an x over there, and the negative divided by a positive class is a negative, and 16 divided by 8 is 2, so we have a negative 2. Okay. We're not going to do a check for this one. Okay. Let's go let's go backside. I don't know why I said that. Just because I have a backside doesn't mean you do. But you may have to turn to the backside of your notebook page by now, because we're going to start another one. Okay, there's our equation. Got x's all over the place and subtractions, and so our first move is what? Add the opposites. So we're going to do 6x. Don't have to change that addition. Leave it alone. That subtraction is going to become plus what? Negative 2x. 2x plus negative 3. Okay. Ready to solve? No? Why not? What's the problem? It's ready to solve? Combine like terms. It's ready to, we need to simplify, don't we? So what can be combined?
6x.
The 6x here and the negative 2x because they're on the same side. When they're on the same side, we get to put them together. So what is 6x plus negative 2x? 4x. At $6, give 2 of it away, you still got $4. Bring the tag along, the plus 5 in the middle, don't forget about it. Can anything be simplified on the right side? No, those are not like terms, so we'll just bring them down. Okay, you all know what to do, finish solving this. Let's see if we all get the same answer. It's ready to solve. Okay, when you finish, look up and see if you agree with me or if you're going to challenge me. Is anybody agreeing with me? Anybody get the same thing I did? Calvin did, Noah did, Dusty did, Abby did, Aurora did, Tori did, okay. My sister getting there. Okay, so I'm guessing that since so many of us got it, we must be right. Is that a good conclusion? We might be right, but we're gonna move on. I gotta see if anybody has any questions about this one before we do. Make sure it's finished up. If you didn't get this answer, make sure you do legitimately get this answer, okay? Okay, the last one. Ready to write it down? Number 4. X minus 1 equals, and I'll be putting it up here also, but x minus 1 equals negative 2x minus 3x plus 3. This is our last equation we'll solve together here. Okay, lots of subtraction going on. How many subtractions are there? 2. Only 2. Is this one a subtraction right here in front of that? No, that's a negative, isn't it? Okay, so I'm gonna stick a 1 in front of that x. I'm gonna change the subtract 1 to add a negative 1. This is a negative 2x. It's not a subtraction. It's a negative sign. Change this subtraction to add the opposite. So it'll be plus a negative 3x. Don't need to worry about that addition. We'll leave it as it is. Okay. Ready to solve? By the way, we actually could go right to word solving it, but we would just end up creating some extra steps that we really don't need to. So that's why we're learning that let's simplify first, and then go to work solving. So what can be simplified? What can be done? Okay, so we combine something can be combined on which side? Right side, and what can be combined? What terms? Are they constants or variable terms? They're variable terms. We're going to put these guys together, okay? So we have our 1x plus negative 1 that are not like terms. They can't be put together. What does this become then? Negative 5x, and then plus 3. Now we're back to a problem that has constants on both sides with the variable terms. So now we get to say to ourselves, I want to make a good decision here and maybe to avoid negatives. Anybody want to suggest what we might make a good move for ourselves so we don't have to be so calculator dependent? There's more than one way we could go about it. I'm just asking for probably the most efficient way to help us not have to deal with so many negatives. Nobody wants to take a stab at it? Come on, help me out. Abby? Plus negative what? Negative 1x? So, what you were saying, Okay, you know what, guys? Because these are negative over here, these are the ones I want to move. What would I have to do? Add them. I'm going to get rid of that negative. I can add 5x, and that will get rid of them, won't it? I'll get rid of that negative. And over here, it's not going to create another negative for me. So now I will have the 1x plus the 5x, which is 6x, and then plus the negative 1 equals 3. Okay, and now I, of course, am going to get the constant out of there because it's on the side with the variable term. And I will have 6x equal to 4 now. Now's when I start to panic because I say, uh-oh, I'm going to have to divide by 6. And how is 6 going to go into 4? We're going to leave it as a fraction. Absolutely, Jesse. You're right. We're going to divide by 6 like we're supposed to. And then the 6's are going to cancel over here. But 6 doesn't go into 4 nicely. So I say, oh, you know what? I guess I better just leave it as a fraction then. But then, you know, ever since, I don't know, whatever grade in grade school, they've been saying you can't leave fractions not simplified, unreduced, yeah. We need to reduce our fractions or simplify our fractions. So what does this simplify to? 2/3. So we're going to actually say that x is equal to 2/3 because that's the one that would be in an answer bank, not 4/6. That's why they taught you to simplify them. So when you're taking a multiple choice test, you would recognize that you have the same answer that they have, but it's just a different name for it. Okay, so any questions at all? Okay, then let's get on a sheet of, well, maybe not. Let me check things out here.